function. Here I had declared one prototype. Here I had declared one prototype called as print underscore per, print person. So this is the function I am introducing here, and that one is called as a function prototype. And here within the function prototype, till now we have the arguments just like the associated with the basic data types. A integer can be an argument, a float can be an argument, a character can be argument, a reference like a pointer can be an argument. Likewise we had seen. Like directly after the introduction of this particular structures, I wanted to introduce you that we can use the structures as well as in the argument list. Suppose whenever we are trying to use the structure as the argument list, by default each and every member or else each and every structure's member will become the part and participle of that particular argument. So suppose if I declare struct data x, then here this particular data x is a formal argument, but x has an amount, x dot amount, x dot first name, x dot last name. Whenever I am trying to say one, x means that particular x will be associated with all the members of the structure. Let us look into the logic of the program. Here I had written one printf statement, enter the donor's first and last names. Then I am capturing that particular donor's first name and last name by using the %s string per.fname, then per.lname. Okay, so both the per.firstname got its value and per.lname got its value from the user. Then comes enter the amount donated in rupees. So I had captured the amount also. So we are right now we have the values of the first name, the last name and the amount for the structure variable called as per. So I want to transfer these particular actual arguments to the function called as print per. So here I have given one formal parameter called as x, but that particular x also, when it is receiving a complete structure variable's values, it also should be of the same data type. So here I am writing struct data, this is the data type, and then I am using a formal parameter called as x. So for each and for this particular x, you have x dot fname, x dot lname and then x dot amount. So x dot lname receives the value of per dot fname, x dot lname receives the value of per dot lname, and then x dot amount receives the value of per dot amt. So in this way I am trying to give three values from the main program. Those are being received by the function that is being given in the next part of the program, and here I am directly printing the values that I had received. Look here, percentages gave donation of rupees so and so. So here both the person's last name, full name will be appearing here and the amount will be appearing at the end. So in this way I can transfer, like I can pass on a function, a structure in the functions argument as I had done earlier in the functions. An array can be passed in the function. Likewise a structure also can be passed in the as a parameter or as a list or as a argument in the function. Next is the combination of structures and arrays. So this particular concept we will be using very widely while doing the C programming. This is nothing but as I told you before, suppose if the variables are very limited, structure variables are very limited. I had designed the blueprint. Suppose if I had designed the blueprint, and suppose if that particular blueprint I have to use it only for two structure variables, then I can declare like structure variable 1 and then structure variable 2, and I can access the members by using the dot operator. But suppose if the same structure, if I want to use it for 30 students or 40 students, then I can't declare stud1, stud2, likewise I can't declare 30 structure variables. So in order to shortcut that particular thing, we have the concept called as arrays concept. Even though that is a similar data items, structure is also a similar data item. So I am trying to take that particular array concept and then I am trying to implement the same concept here also. So there is a structure, student structure here with 5 structure members, and then the variables I am taking are 20. So how I have to write it? Struct student std, I have to open an array and I have to declare the size also. Likewise, like I had done it here. Like size of here the size I had taken is 20. So in order to access the first student's data members, the value, suppose if I want to initialize, for the student 1, what will be the thing? STUID, within the square braces I will put 0 for the first student, dot operator, roll number. I can give any roll number. Then likewise STUD, within brackets 0, I can put the name and I can initialize any name by giving the 2 double quotes. Likewise I can initialize the marks by providing this particular subscript. So as 0 for the first student, 1 for the second student. Likewise I can take n number of values. Look here, I had given, this is the program I had written. Struct a student of size 20, and then this is the structure, this is the portion I had given, but the same structure I can use it here. I haven't declared the structure, but I am taking the values for from 0 to 19. That is nothing but for 20 students I am capturing the values, and then I am trying to store that particular values, and then I want to try to print out at the end of the program. So in this way, suppose if you are maintaining it for 20 students, if you are capturing all the values like the roll number, the name, then the marks, then the average, the grade, like it is nothing but you are maintaining the record. So whenever you are maintaining the record means that pertains to one student. Likewise here you have 20 records. So for a class of 20 strength, you are maintaining the records of all the students, like enrollment number, all the enrollment numbers for the students, the marks for the students, and you can calculate depending upon the values. You can calculate them and you can store them in the form of a file. Suppose if you are storing all this data by opening a .dat file using the file handling techniques of C, then that is nothing but that particular file is nothing but a kind of database that you had designed using the C procedural language. So you are maintaining the record .dat file by consisting all the records, all the items, all the records of the students. So in this way, in C programming, we use the structures concept in order to produce the records, and we use the file handling concept in order to store those particular records. So here whenever we are not, like in this program I haven't used the file handling techniques, but in the file handling techniques what you will be doing, you have to open a file by using the function called as fopen. You have to open that particular file. You can store all this data. You can directly store fscanf or fprintf and then fscanf, and you can store all the data, transfer all the data to that particular student.dat file, and you can store the information. Suppose whenever you had finished storing all the information, you can close that particular student.dat file using fclose statement. Suppose if you want to use to calculate the total marks obtained in all the 3 subjects, then you can open a program, like you can write a program to calculate all the subjects marks by putting one for loop, and then calculate all the subjects marks and for a student, and then for all the students you can calculate the marks, and correspondingly you can place the percentages, and correspondingly you can place the grades. So in this way, using the structures concept and using the file handling techniques of C language, you can maintain the databases in C. Sorry. Then another important structure similar to that of the structure is the union. Unions are similar to structures in all aspects. Like you have the keyword called as union. You have to declare the union with the union tag, and then you will be having, just like structures, you have the members of the structure. Similarly, you will be having members of the union. A union is declared and used in the same way as the structures. But the basic difference between the structures and the unions is nothing but the way it handles the memory space, or else it holds the data. It holds only one object at a time. Like whenever we are trying to focus on the structures, like I told before, that whenever we are trying to produce one structure variable, that is nothing but we are allocating the space for that particular structure variable, as we had calculated 47 bytes in case of a student structure. Likewise, for each and every structure, whenever we are trying to declare, it obviously will get the memory space. But whenever we are trying to get this particular unions, the union at any point of time we can handle only one object. This is nothing but it won't provide the complete space it requires for all the members to store. It will identify the biggest space that is being required for the biggest member of the union. Then that particular thing is fixed, and for all reasons, for all the members of that particular union, it tries to access only that particular memory portion. Let me show you one example so that you can understand. This is a comparative thing. In a structure, each member has its own memory location, whereas members of unions have many memory locations. Since all members of a union occupy the same memory and storage space, the space allocated for a union member is equal to the largest data member of the union. Hence, the member which has been updated last is available at any given point of time. So let me show you one example. This is the syntax similar to that of the structure, and this is the example. Here temp is a union, then int x, character y, then float z. Here I can access at any point of time, I can access only one member, that I can handle only one member in that particular union. So the total memory space I will be getting for any point of time is the highest value. Like float occupies 8 bits. Float occupies 8 bits. So float occupies 4 bits. So that particular 4 bytes memory space will be given, and that particular 4 bytes will be allocated to the whole union. At any point of time I can use the 4 bytes in order to access the union. So with this I want to conclude the session. In this session we try to learn what are structures, how to declare a structure, and then how to declare the structure variables, what are unions, how to declare a union, what is the difference, basic difference between the structures, and what is the basic difference between the structures and unions. This particular thing we have studied in this class. In the next class we are going to see the pointers. Thank you very much. Good day.